Ch-10.
Dear students, in my today's lecture, we are going to study capacitor and capacitance. In 11th standard, we have studied one electrical component whose name is resistor. And this resistor allows the flow of current through it, and heat is produced in the resistor when the current is flowing through it. But this component, resistor, does not store electrical energy. So, in order to store the electrical energy, a new component or electrical device is developed, and that is known as capacitor. So, capacitor is nothing but it is a system or it is an arrangement of two insulated metal conductors having equal and opposite charges. So the system formed by insulating metal conductors having equal and opposite charges, and these two plates are separated by a small distance, or the space between these two conductors is filled with insulating medium, that is K, or dielectric medium. So in this arrangement, the magnitude of charge on either plate of the conductor is Q, and due to this charge which are deposited on the metal plate, its potential increases. So due to charge, potential goes on increasing, and this potential is directly proportional to the magnitude of the charge, and therefore we write Q by V is equal to constant, and this constant of proportionality is called as capacitance of a capacitor. So, capacitance of a capacitor C is equal to Q divided by V. So, the system or arrangement formed by two insulated metal plates having equal and opposite charges separated by a small distance, and the space between them is filled with dielectric medium, such a system is called as a capacitor. And when charges are deposited on the plates of the capacitor, electric potential is directly proportional to the charge, and the ratio of Q by V is constant, and this constant of proportionality is called as capacitance of the capacitor. So, capacitance of the capacitor is equal to C and is equal to Q divided by V. And this can be defined as it is the ratio of magnitude of charge on either plate of the conductor to the potential difference between two plates of the conductor. So, capacitance of a capacitor is nothing but the ratio of magnitude of charge on either plate of the capacitor to the potential difference between the two plates of the capacitor. And from this expression, the SI unit of capacitance is Coulomb per volt. So this is one of the unit of capacitance of the capacitor, which is Coulomb per volt. But in the honor of scientist Michael Faraday, the unit of SI unit of the capacitance is farad. So farad is a larger unit, and the smaller units of capacitance of the capacitor are millifarad. So 1 millifarad is equal to 10 to the power minus 3 farad, microfarad, and 1 microfarad is equal to 10 to the power minus 6 farad, nanofarad, which is equal to 10 to the power minus 9 farad, and picofarad, which is equal to 10 to the power minus 12 farad. Now, this capacitance of the capacitor is independent of the charge and potential, but it depends on the space between the two plates of the capacitor, which is filled with the dielectric. Again, this formula for capacitance of a capacitor can also be written as C is equal to Q divided by V. As we have studied in standard 11, the relation between electric field intensity and electric potential is E is equal to V by D, and therefore the value of V is E into D, and hence the another formula for capacitance of the capacitor is equal to C is equal to Q divided by E into D, where this E is the reduced electric field when the dielectric is introduced between the two plates of the capacitor. Then on which factor this capacitance of the capacitor depends? So, capacitance of the capacitor depends upon shape and size of the conductor. So, capacitance depends on number one factor, size, number two, it depends on shape, and number three, separation between two conductors forming a capacitor. Now, depending upon the dielectric medium which is present between the two plates of the capacitor, the capacitors are divided into different types, and the symbol for this capacitor is two parallel lines separated by a small distance, and this is the symbol for fixed capacitor, and in between these two plates a dielectric medium is introduced, which is K. And which dielectric medium is introduced, and depending upon this the capacitors are of different types. So first capacitor is called as air capacitor. If the field is filled with mica, then it is called as mica capacitor. Or between two plates, medium is paper, then it is called as paper capacitor. Synthetic film capacitor, electrolytic capacitor, oil-filled capacitor. So depending upon the dielectric medium which is present between the two conductors forming a capacitor are air capacitor, mica capacitor, paper capacitor, synthetic film capacitor, electrolytic capacitor and oil-filled capacitor. Again, depending upon the shape of the conductor forming capacitor, again these capacitors are of three types. So these capacitors are again of three types. One is parallel plate capacitor. Second one is spherical capacitor. Third one is cylindrical capacitor. So depending upon the shape of the conductors which forms the capacitor, there are again three types: spherical capacitor, parallel plate capacitor and cylindrical capacitor. So in first type of capacitor, which is parallel plate capacitor, it is formed by, this capacitor is formed by two parallel metal plates separated by a small distance, and space between them is filled with dielectric medium having constant K. So charge positive is deposited on one of the plate and charge negative minus Q is deposited on another plate. So equal and opposite charges are deposited and the other plate is connected to earth. So why this another plate is connected to the earth, we will discuss this article later on in this my lecture. So in case of parallel plate capacitor, the capacity with dielectric is given by A K epsilon 0 divided by D. Now second type we have discussed, which is known as spherical capacitor, and this spherical capacitor is formed by two spheres. One sphere, which is inner sphere, having radius equal to suppose Ri, and charges are deposited on this sphere, and another concentric sphere which is connected to the earth, and it acquires a equal amount of negative charges, and the space between these two spheres is filled with dielectric again. Then In this case, the capacity of or capacitance of spherical capacitor is given by formula 4 pi epsilon 0 k in bracket Ri into Ro divided by Ro minus Ri, where Ri is the radius of inner sphere and Ro is the radius of outer sphere. And depending upon the shape of the conductor, third type is cylindrical capacitor. And this cylindrical capacitor is formed by two coaxial cylinders, one cylinder having radius which is equal to, again suppose, Ri, and charges are deposited on this sphere. Equal amount of positive and negative charges are deposited. Again, this conductor is surrounded by another coaxial cylinder and whose radius is, suppose, Ro. And due to induction, again negative charges are induced on this second cylinder which having radius equal to Ro, and again this conductor is connected to the earth. So outer plate or outer conductor is always connected to earth, and reason behind it is capacity of the capacitor is increases. And in case of this cylindrical capacitor, again capacitance of cylindrical capacitor is given by formula 2 pi epsilon 0 k into L, where L is the length of the cylinder, divided by 2.303 log of Ro divided by Ri to the base 10. So depending upon the shape of the conductors forming a capacitor, three types we have seen, and for these three types we have seen the formula for capacitance of that particular type of capacitor. Now we will discuss the applications of this capacitor. So as capacitor is an electrical device and whose capacitance is given by the formula C is equal to Q divided by V. So as C is equal to Q divided by V, from this equation we observe that if the value of this V is small, that means PD between the two conductors is small, then the value of this capacitance is very, very large. So capacitor is also nothing but a device which stores large amount of charge at comparatively low potential. So this is the first application of capacitor. Number one, stores large charge at low potential, and this is useful in nuclear reactor. Second case, it produces uniform electric field. Number 3, it is used in tuning of radio receiver. That means particular station in radio can be adjusted by adjusting the capacitor. Again, this capacitor blocks DC and which allow AC to pass through it. So direct current are blocked by the capacitor and alternating currents are allowed by the capacitor. Again, this capacitor is used in resonant circuit, and in resonant circuit these capacitors are used to select or reject a particular frequency. So in selecting a particular frequency or rejecting a particular frequency in resonant circuits, series resonant circuits or parallel resonant circuit, and this article you will be studied in the chapter electromagnetic induction or AC circuits. And again this capacitor is used in ignition system of automobile engine. And finally, the application of this capacitor is for smoothing rectified current in power supply. As we are use power supply in our home, then to rectify the current we use rectifier, and this rectifier current is smoothened by the capacitor in power supply. This article, capacitor and capacitance, we have studied the formula for capacitance of capacitor. C is equal to Q by V, or this formula can be written as C is equal to Q divided by E into D. That means this capacity of the capacitor will depends upon mostly on electric field. That means decreased or reduced electric field when the dielectric is introduced. And this capacitance of the capacitor, as we have discussed, does not depends on. So this C does not depends on Q or V, because as the equal and opposite charges are present on the two plates of the conductor, the resultant charge on the system Q, which is equal to 0. Now in next article we will discuss the concept of capacitor. Or this concept of capacitor is also known as principle of working of capacitor. So concept of capacitor or principle of working of the capacitor. And in this article, suppose that an isolated conductor which is P1, and this isolated conductor has given a charge which is equal to plus Q. This is figure number 1. So only single conductor is taken, and on this single conductor positive charges are deposited. And as on this conductor charges are deposited, then due to charge on this metal plate P1, its potential goes on increasing. And therefore, by the definition of capacitance of the capacitor, C is equal to Q by V. For this figure, the C is equal to again Q by V. Or we say that for plate P1, it is C1, and which is equal to Q by V. Now, initially we have taken the metal plate P1, which is an insulated metal plate, and on this metal plate positive charges are deposited. Now, if another metal plate, which is also insulated metal plate, P2, is bring near this plate P1, then due to induction, equal amount of negative charges are induced on inner side of plate P2, and equal amount of positive charges are induced on outer plate of the P2. So due to induction, charges are induced if another metal plate is bring or kept near the charged conductor plate P1. And as the negative charges which are inside the plate P2, which are near to plate P1, therefore the potential of plate P1 goes on decreasing. And in the similar manner, the charge on P2 outside it are positive, due to which the capacitance of the plate P1 goes on increasing. But now in this case, figure number 2, we have seen that due to induction process, negative charges are induced in the inner surface of the plate P2, and equal amount of positive charges are induced on the outer face or outer surface of plate P2. Now, in third case, suppose again as usual our plate P1 has charges plus Q, plate P2, inside the plate P2 there are charges negative. Now this plate P2 is connected to the earth. Then the positive charges which are outside the plate P2 in figure 2 are escaped to the earth, and only negative charges are present on inner side of plate P2, and due to this the potential of plate P2 is V2, and the initial potential of this plate P1 is V1. So C1 is equal to Q divided by V1. Now in figure 3, when another plate is connected to earth, the charges which are present on the outer surface of plate P2 escapes to the earth, and hence for figure 3 the potential of plate P1 is V1 and potential of plate P2 is V2. And due to this system formed by the two conductors, in which one of the conductor is connected to the earth, the net potential is V1 minus V2. So net potential between the two plates P1 and P2 is V1 minus V2, and therefore the capacitance of this system, which forms the capacitor, and it is known as parallel plate capacitor. So capacitance is equal to C2 is equal to charge is Q divided by potential difference is V1 minus V2. So if only a single conductor is taken, then we have obtained the formula. The capacity of isolated positively charged conductor is C1 is equal to Q by V1, and if another conductor is kept near the first positively charged conductor and second conductor is connected to earth, then we have get the capacitance of the system. That means a parallel plate capacitor is C2 equal to Q divided by V1 minus V2. As in this equation number 2, the denominator consists of V1 minus V2, that means potential is decreased in equation 2, and therefore the value of this C2 must be greater than C1. So if we compare equation number 2 and equation number 1, we obtain or we conclude that C2 is greater than C1. That means when another identical metal plate is bring near the positively charged metal plate, and other plate which is connected to the earth, then capacity goes on increasing. And this is the concept of parallel plate capacitor, or simply concept of capacitor, or it is also called as principle of working of a capacitor. So in words we say that the capacitance of a conductor can be increased by keeping another identical conductor and this identical conductor is which is uncharged, it is not charged conductor, and this uncharged conductor is connected to earth. Then what happens? Capacitance capacity of a conductor increases. So this is the principle of working of the capacitor.